Hey everybody, welcome to our very first video lesson for Unit 1.2. Today we're going to be reviewing minimums and maximums, and then we're going to use this new idea of interval notation to talk about increasing and decreasing parts of a function. So if you have not done so already and you need the refresher on calculator commands for finding minimums and maximums, please pause this video and switch over to that one before getting into our lesson here. So as a review, local minimums and maximums are the highest point of each hill on the graph or the lowest point of each valley. An absolute minimum or maximum would be the highest point of all the range values for the entire function or the lowest point of all the range values. Okay, a couple notes to make about local and absolute. So there may not be a relative or an absolute minimum or maximum for every given function. Okay, and sometimes the word relative is used to replace local, but we know that those mean the same thing. Okay, and additionally, a local max or min does not have to be the overall maximum or minimum of the function. It only has to be the maximum or the minimum on some small interval of the function, meaning we're just peering into one little window of the function and right there, blocking out all of the rest of the graph, that is the highest or lowest point. All right, so I want to just take a look really quickly at these two functions. On your end, you're going to be typing them into your grapher as we go, okay? And we're just going to identify what is the absolute, if it's a local, whether it's a minimum or a maximum. All right, so starting with function number 1, in your grapher, plug that into your y equals screen and then go ahead and hit graph. And if for some reason your graph is not showing up or it's not quite centered, you could hit zoom 6 and that should bring you back to a nice middle ground screen. Okay, so I'm going to draw a little sketch here of what our function should look like when you bring that up on your grapher. Okay, so whether you're using a handheld grapher, the app that I showed you in the previous video, maybe you're using Desmos. All right, but so I'm going to identify the peak of that hill and the valley here. I'm going to identify those as points A and B. All right, so just peering into, zooming in on point A right there, okay, that is the highest point just for that specific area of the graph. Now, if I look at the big picture here, I see that one of the ends of the function extends all the way up the graph. So that means that there's always going to be overall some point that's bigger than point A. However, in that small area, that is the maximum. So that's why we consider point A to be a local. So you could use local or relative. And the same idea for point B. So looking in just in that specific small little area, it does look to be the lowest point. But if I look at the big picture of the function, I see that that left arrow is pointing down for infinity, meaning that there is always going to overall in the function be a smaller value. So again, that means that point B is a local or a relative minimum. All right, so using your graphing calculator, if you want to pause the video and calc each of those values. Okay, we do have our local maximum, that's point A at 0, -1. You could also just say x equals 0, I'm fine with that. And your local minimum, that's point B, would be x equals 1.3. Okay, so hopefully you didn't have any trouble plugging that into your grapher, finding the min and the max using that second trace function, and then identifying whether they were local or absolute. All right, so we're going to do the same thing now for example 2. We're going to plug that function into our grapher, and I'm just going to get us a quick little sketch here of what this should look like. So I am plugging it in on the grapher on my end, okay, and I'm getting this kind of off-center W here. Okay, so I see I have a couple of points going on. I have A, B, and C. Okay, well, this one's a little bit different because point A happens to be the overall lowest point on my graph. If you notice, the ends are continuing upward. So there will always be something larger, but there will never be anything smaller. So A, point A, is an absolute. Okay, and again, it's an absolute because there are no other points smaller than that. Point C, however, I'm going a little bit out of order here because I want to identify the difference. Point C is just a local minimum. And then B, that's also going to be local. This one is a maximum though, okay, because it's at the top of the hill. And it's only a local, again, because the two ends of the function are continuing to increase upwards, meaning there will always be something bigger. Okay, so if you use your grapher to calc, okay, two minimums and a maximum, so the grapher doesn't care if they are absolute or local. Okay, but so for that we should get these ordered pairs, or again, we can just use the x values. All right, so any of those, if you want to give the whole ordered pair, you totally can. If you want to just give the x value, I'm fine with that. Okay, so we're gonna use this idea of, minimums and maximums to help us talk about increasing and decreasing intervals of a graph. So hopefully you remember we read a graph from left to right, and when we're determining increasing or decreasing, we're going to follow that same progression. So if the function is rising, so as we read it from left to right, we're essentially going to retrace the steps of the graph. So I like to actually trace the line, and we're going to see if it's rising, that means that the function is increasing. Okay, if the function is falling, if it's coming down as you move from left to right, that's a decrease. And also if it stays horizontal, okay, it does not rise or fall, that is constant. Okay, so constant is another option as well. Okay, and functions are going to switch between increasing and decreasing intervals at critical values. So think for a moment, what is possibly a critical value on the graph of a function? Okay, so the critical values are the minimums and the maximums. So that's why we just went over how to find those on the grapher, because we need to know those x values in order to describe the intervals where our function is rising and falling. So if we just look at this graphically really quickly, okay, we're not really getting into the interval yet. We're just trying to identify if it is increasing or decreasing. So I'm going to trace graph A. I'm going to start from the left to the right. So starting on the left actually puts me at the bottom. So if I retrace the steps of the function, okay, and as I do this the entire time, okay, my function never stops rising. Okay, even though it bends a little bit there in the middle, it is actually continuing to rise. So graph A is increasing across the entire function. Okay, and a similar idea in graph B, if I wanted to trace that starting from the left, we're actually up at the top now, and as I trace what this did from left to right, it never switches. Okay, it's just a continual smooth fall of the function, which means that this entire thing is a decrease. Now we'll see the difference in C and D as we retrace these steps. You can see how the function kind of stops and changes direction. So on graph C, if I start from the left, okay, as I trace this, it's ever so slight, okay, but the function is actually falling as I come in from the left. So this portion over here is a decrease. And as I go through the middle, well, I haven't changed at all. If I haven't risen or fallen, okay, that means it stayed constant. And we can see now after this horizontal line, it changes direction again, and ever so slight, it's back on the rise. So this is an increase now. So this is where the interval notation that we're going to talk about in a minute is going to come into play. So graph D really quickly, as I start from the left, I'm down here on the bottom and I retrace this, okay, and I come up to the top, and you can see it begins to change direction when it gets up here. So until I get to the top, it's a rise. So it's an increase there. When I finally arrive at the top, okay, so at the very, very top, it is neither rising or falling, okay, it's just kind of stagnant for a moment. And then it starts to come down. Okay, so if it's falling, that's a decrease. So it falls all the way down to this minimum, and again, stagnant at that specific point, and then as it turns at that critical value, it begins the rise again, and it's an increase, okay? So you see we actually have two portions of the graph that increase here, and one that is a decrease. So now we're going to put this information into intervals. So if you haven't seen interval notation, we're going to start from the very bottom and build our way up. Okay, so interval notation uses brackets and parentheses to describe the x values that we're indicating. So brackets are used when a value is included. So on a number line, you could equate a bracket to a closed circle. Okay, because a closed circle means that it's included. A parenthesis is used in the interval when it's not included. So that's kind of like an open circle. All right, and we can mix and match in an interval. One end could be a bracket and the other could be a parenthesis. Okay, so you can see this bracket -3 to 2 with a parenthesis. So the -3 is included, but the 2 is not. Okay, so that means we go all the way up to 2. Okay, so all of those like little decimal values in between 1 and 2, you want to make sure that they're included, but not the actual number of 2. Okay, a couple other things that you want to make note of if you don't already know. Infinities are always used with parentheses. Okay, we cannot bracket an infinity. And when we come to an absolute or a relative minimum or maximum, when we describe increasing and decreasing, we can never include that as increasing or decreasing, because we just mentioned on those graph representations that at those actual critical values, the graph is stagnant. So it's not considered constant really, it's just kind of like free floating for a moment. Okay, so we don't include the actual minimum or maximum critical point. And I'm going to show you that when we actually do some examples here. So when I start from the bottom up of building interval notation and learning how to write this properly, I like to start with a number line and an inequality. So I want to turn the inequality of x is greater than 5 into an interval. Okay, so if you put this on a number line, okay, you would use 5, and you know it's an open circle since it's not included. So if we want greater than 5, that's everything that is to the right. So I would shade there. Okay, the values that you're going to put into your interval are going to be what you shaded on the number line. So we always start an interval from the smallest value that we're using. So again, you read the number line from left to right, just like you read a graph. So I'm starting on the left, where my shading begins is at 5, okay? And the open circle indicates that it's not included. So I'm using a parenthesis on that 5. Now, as I go out to the right, there is no endpoint to my shading. Okay, so another thing to note, the left side of a number line is always negative infinity, and the right side of the number line is positive infinity. So if this shading has no bound on the right side, it's going to go all the way to positive infinity. And remember, we said a minute ago that we always parenthesis infinities in an interval. Okay, so now we're going to have one that's a little bit more complicated. So now I have two values. So -2 and 6. Now the -2 is equal to, so that's going to be a closed circle. Okay, so think to yourself, what does a closed circle equate to in an interval? And 6 is an open circle. All right, so if we are less than 6 and greater than -2, well, our shading must be here in the middle. Okay, so remember, only the shading is what is put into your interval, and you always go from the left to the right. So we're beginning at -2, and it is bracketed because of that closed circle. And the shading includes everything up to 6, but then we do not include the actual value of 6 in our interval. Okay, so if you have not seen interval notation before, hopefully this is a nice introduction for you, and you can use these number lines to assist you when you're trying to build that notation. Okay, so we're just going to use the grapher really quickly to produce these functions. And if we're doing increasing and decreasing, we know that we're going to need our critical values, which are the relative minimums and maximums. Now, in order to do increasing and decreasing, you don't actually have to label if it's relative or local. You just need the value. Okay, so function number 1 is a quadratic. So plug that into your grapher into y equals. And you should get a function that looks like that. Okay, hopefully you can see that there is an absolute minimum. Again, you don't need to know that it's absolute for this necessarily, but you do need to know that there is a minimum there that you should calculate. And that happens at x equals 0. Okay, so we're going to trace this function from the left to the right, and we're going to stop at critical values. So as I trace this left to right, what is my function doing? Okay, the function is falling, which means that it's a decrease. So think of the x-axis as your number line. So the left side is negative infinity, and the right side is positive infinity. So where does the function come in from? It comes in from the left side at negative infinity. We're using the x values to describe. So from negative infinity up to, but not including, the minimum of 0, this function decreases. At that value, at that critical value, the function is going to turn, and it's going to begin to increase. So from 0 out to what value does it increase? Well, that arrow keeps going to the right. Okay, as it moves upward, it is going wider and wider. It's going out to the right side of my x-axis, my number line, which is going towards positive infinity. Okay, so I have two separate intervals. You do want to indicate if it is increasing or decreasing. So I'm decreasing from negative infinity to 0, and remember, it's not actually included. And then I turn and I increase from 0 to positive infinity. Okay, we're using the x values here. So think of the x-axis as the number line that we just used in the previous example to kind of learn how to write interval notation. Okay, example 2, if you plug that into your grapher, okay, the function looks like this. So before you try and figure out if there are minimums and maximums here, I want you to just trace the function and tell me if it ever takes a turn. Okay, so I'm just tracing this over and over again, starting from the left, which comes up from the bottom, and I go out to the right. This function never takes a turn, which means that it's increasing across its entire existence. So from the left side of the graph, which is at negative infinity on the number line, all the way out to the right side of the graph at positive infinity, the function never stops increasing because it never takes a turn. So this only has one interval, which is an increasing interval, and it's from negative infinity to positive infinity. Example number 3 now. Okay, even though it's the same power, it's a cube, as example 2, the graph is going to look different. Okay, so when you plug this into y equals on your grapher, you get something that looks like that. Obviously mine is a little off. Be gentle with me. Okay, but I'm going to find these critical points. So this is a local max, so we're going to do second calc. Okay, if you need to pause your video in order to calculate those before we move on, absolutely do so. So that maximum is at x equals negative 0.8. Okay, remember, we only use the x values to describe increasing and decreasing intervals. So that's why when we did the minimums and maximums, I didn't really stress that it had to be an ordered pair because we only have to use the x portion. Okay, and then I have a local minimum here. When I calc that, I get x equals 0.8. Okay, so all of these critical values, I'm using the grapher to find those for me. So, as I trace this function coming in from the left, okay, I'm asking myself, what is the function doing as I get to that local maximum? Is it rising or falling? Okay, so I can identify that this is rising, which means that it's an increase. Okay, from the maximum to the minimum, what is it doing as I move from the left to the right? It's falling, so a decrease. Okay, so at this point in time, if you could at least identify what portion of the graph is rising and falling, that would be a huge win. Okay, and from this minimum out through the rest of the function, what is it doing? Is it rising? Is it falling? Okay, it's rising, so that portion is an increase. So we can see here that we have 2 increasing intervals and we have 1 decreasing. So when we have 2 of a type, whether it's increasing or decreasing, we're going to link them together with something called a union. So the left side of my number line, remember, is negative infinity, and the right side is positive infinity. Okay, so as I begin my first increasing interval, I'm starting at negative infinity because I'm coming from the left there. Okay, and that arrow indicates that it had been coming in all the way from the left. Okay, and it's increasing all the way up to negative 0.8. Okay, and that's where it stops. So from negative infinity to negative 0.8, it has increased. Okay, and then remember, it took a turn. So when it turns, it decreased. So now that creates a different interval for us. So in between negative 0.8 and positive 0.8, I have decreased. So that's my next interval. I'm going to write these all out for you in a second. Okay, and then we go back to increasing. So it begins increasing at 0.8 and it continues to increase all the way out to positive infinity. Oop, so sorry. Okay, so we lost our graph, but we already had that information. So you see here, the increasing interval is the important thing to note for example 3. So since there are 2 portions of the graph that increase, we're going to link them together with a union. So we don't just infinitely, list increase, decrease, increase, decrease, increase. Okay, we want to link those together so that we have one increasing interval and one decreasing. Okay, and again, I cannot stress enough that we need to have parentheses around the actual critical values themselves. Okay, because nothing is increasing or decreasing at that actual value, so we can't include that anywhere. All right, so the last thing that I'd like you to do as part of your notes is try and complete this example on your own, okay, kind of as an exit ticket. So I want you to plug that function into your grapher, sketch a graph, label the minimums and maximums, whether they're local or relative, and use the grapher to calc that, okay? And then you're going to write your increasing and decreasing intervals. Okay, so I want you to submit that as part of your notes as well. I am going to check this question, okay, at the bottom of your notes, and that's going to be the first thing that we go over when we're together in class. All right, so if you guys have any questions, please write that down as part of your notes as well so you do not forget until we are together again. I hope that this went smoothly for you. All right, I thank you guys for watching, and I will see you soon.